and welcome everybody to the February 6th, 2025 session of the Technical Advisory Council of the Confidential Computing Consortium. We get together bi-weekly and do work in between in order to promote the use of confidential computing and hopefully make the world a harder place for the bad guys out there. We have to abide by the antitrust policy of the Confidential Computing Consortium and or rather the Linux Foundation. The CCC is a project of the Linux Foundation. And if you want to learn more about antitrust, in the mail lists, you can find links to training that the LF actually provides from that if your company doesn't have something similar. Today, we have a bunch of announcements to talk through, and then we have a continuation of our discussion on workload identity. We have Mark on the call to talk us through that. And then we are also blessed by a couple of interesting tech talks. And I see Jakob and Jens both here for their respective talks. And then time permitting, we'll take a look at what's coming up for the next meeting. Have I missed any topics in the agenda that people were expecting? Okay, so these are the voting members that come from the premier companies, and we try to minimize the number of votes we do so that we're really just more of a collegial group. I did have regrets sent from Paul and from Alec, who both got called away on short notice today. And then Yash also mentioned he's going to have to drop in and out for a meeting that popped up. Do we have Catherine? I don't see Catherine. Nathaniel, no Nathaniel. Also missing Henry. Okay, but thanks to Fritz for being on. Do we see Ming Chen? No. So not a great turnout from our voting reps today. However, most of you on the call then are not voting reps, and if you haven't had a chance to introduce yourself in the community, feel free to pop off of mute and let us know how you like to be addressed, where you're calling from, and what your interest in confidential computing is. Okay, well, we usually don't call on people in case they really don't want to talk, but if you want to introduce yourself, you're welcome to do that as we go. And everybody is welcome to contribute constructively on the call. There are no dumb questions, and there are only positive contributions here. Last time we touched briefly on workload identity. Mark's back today to talk about that. We had the newest project proposal to the CCC, the OpenHCL and OpenVMM project that Caroline presented. That's now working its way through the other project formation steps. We took a vote in the meeting, and we took some offline votes from people who were not available. Did we actually get votes from the people who were offline that you reached out to over email, Rian?
Yes, we did get one or two more, even though we have already had an approved vote in the meeting. But yes, we gathered some more, and we're going through the legal process. Was in communication with them this morning. They're going through all the steps.
Okay. And then do we have those email votes recorded in any minuting or on the mail list or anything?
We have a voting record that we keep on the side in a file, so it would be updated in the voting record.
Okay, maybe that's something we can just kind of, those couple votes we could add to the minutes for this week.
Okay.
Just so they're kind of publicly out there that we had support or concern or whatever the votes were from the other people who weren't here.
Only supporter votes, but we'll add them.
Okay, great. And then we had Tech Talk on decentralized storage. from Magic, and that was most of what we talked about. One of the few governance things that we are required to do in order to show that we've got proper transparency in what we've discussed are having formal minutes. So I appreciate Mingshen, Fritz, and Yash from having done a lot of the recent reviews of those minutes. Other TAC voting members like to see your involvement on that as well. But moving into today's announcements, Renu, would you like to speak to this one? Catching you off guard there with the first announcement.
Oh yeah, sure. No worries. So yeah, this is with regards to the annual project update. So I have sent out an email with the list of the projects which are falling under respective quarters for their annual reviews. However, I have received two of the confirmations with respect to the TAC meetings in which those projects can be represented. So I would request from the rest of the stakeholders to submit their dates from the provided slot of the TAC meetings on which they can present their projects, how it has been going on for the last 1 year, and providing any other information with regards to that. Also, if in case you need any other assistance from the community. So, thank you so much to Bodek, who has already responded, as well as for the other projects. So, that's all about it. Thank you, Dan.
All right, thanks, Renu. That is a recurring topic for us. We run through our projects. We now have more projects than ever, and so we're going to end up with roughly one for each month, I would guess. And for each one of these projects, we had originally had a project liaison, someone from the TAC meeting to kind of keep in touch with the projects, help give them a heads up on things that are happening, or hear things from the projects to give a heads up to the TAC. Next time, we probably want to have a discussion about this again, because this list is pretty good, but there's a couple names here that are out of date, and want to make sure that people are cognizant of these responsibilities. Yeah, and so I've kind of skipped over this Kernel Sig one. The schedule had gotten out of sync over the new year, and so I think we are rescheduling that and shifting the European time. It was like Friday nights Europe time, which kind of hard to compete with Friday night, as exciting as confidential computing is. So I think that has been changed or will be changed. And I was looking for Catherine for finalization of that. But maybe if Catherine joins a little bit later, we can check back in on that. A new announcement on sanctions went out on, I think, the mail list. I think this got circulated. But Mike offered to explain a little bit about that. If you'd like to take a couple minutes on that, Mike.
Did I? Well, it's foolish of me.
Yeah, it's
Yeah, so I keep thinking of these as Olaf sanctions, but that's a reindeer from a different movie. So basically there's a whole bunch of new sanctions which are not the same as the previous sanctions that we've been able to work with. And they are very restrictive and can cause real problems. And your companies need to look at it. The LF has put in place a system, a process whereby it will be checking regularly to see if any of the members of the LF, and therefore any members of the project, may fall within that sanctions bucket. If they do, we need basically to stop working with them. It's tricky, but there's a list of undesirable companies, I guess you could think of it, and who owns them. If you have 50% more ownership, and that, it's not even direct ownership, it can be further down the chain or up the chain, depending on how you look at these things. But it's very restrictive, and I think all we can do is say, if you or your company become aware that there may be a restriction on one of the companies that we're working with in the LF or the CCC or in other groups via projects, please let Renu or Rian know, and they're positioned to take the best action. If this is not something you wanted to get in trouble with, and it's one of those ones where not being sure or not knowing is not an excuse. You have to go out of your way to try and find out, which is why the LF has put this stuff in place. So be aware, if you're doing work with companies that there may be concern about, please raise with the right people which is basically our LF colleagues. Rian Renew, has that covered it in enough detail, do you think? And there is an article that's worth reading, if we could put that in the minutes as well, please.
Yeah, that more or less covers it for companies, but it also speak to individuals as well that are related to those companies, and
Yes,
contributions to your project. So it does get a little complicated. If you read the article, you'll see there's quite several examples of how we should be looking at this. Not to scare anybody, but it is important we keep an eye on this. So I'll
Yes,
share
thank
the
you.
link for you shortly.
Thank you very much.
Great, thank you. And since we often get questions about like, well, what's the benefit of being in the CCC? What's the benefit of being in a Linux Foundation project? We've got professionals, open source professionals, to help out with these kinds of problems. So for those of you in particular who are liaison to the projects, this is something to help make sure that they're aware of that. There's the Olaf sanctions for you, Mike.
Oh, thank you, Marvelous.
Yeah.
I thought it was the reindeer that was called Olaf. Was that the? I don't know.
No.
It's quite a
Add it
long
back
time
to
since
your
I watched
studying.
it, frankly. Yeah,
Okay.
indeed. So I had another point I'd like to raise, whether now
Sure.
or later on. Is it now okay? I just suddenly realised, which is that the CCC is starting a job board, which is open to anyone who is a CCC member can post jobs from their company or their project. And if you're aware of any of these, please let us know, because we basically need to start it. Anyone can look at it. There will be on the Slack channel, but also we'll have a web page up to spread the word. So that's another benefit, hopefully, of being in the CCC, because job adverts are expensive to do in useful places, and we hope that this will become a useful place for CC related jobs. Thank you.
And the web page is coming soon, or it's up already?
It comes as soon as we have our first job ready to
Okay.
go, I think. I think Rian, you may correct me if I'm wrong, but I think that's what we're just waiting for the first one, and once it's there, it happens.
Yes, first one to send a job my way, I'll get the web page up. Then a further, if I can interject, a further thing that we discussed, which would be very handy, if people can write articles for that page that says, if you want a career in confidential computing, these are the type of skills you need, or this is how you start, or this is where you go to learn more, specifically about technical skills around confidential computing. That would be helpful to people coming to the page to find jobs, to realize what skills we're looking for as member companies.
That's great. And I think we'll talk more about skills and intro content 1 or 2 meetings from now.
Thank you.
And that leads us to other sorts of interesting information to know about. Tech Talks, we got a couple of those scheduled today. These are from the backlog that we generated in 2024 still, so appreciate the patience of our presenters there. Because we had such good traction with Tech Talks last year, we can start to be more prescriptive about the kinds of things that we're looking for. And because the consortium as a whole is working on things like confidential AI, securing devices, whether those are GPUs for accelerating AI workloads, or the sort of the rise that we're seeing of secure NICs, other sorts of devices that have TEs. These are all good talks for us to get educated. We're going to be talking about workload identity today, but there's a whole lot of individual areas within that. If there's other areas that we think are aligned with the overall goals of the consortium, maybe we'll just take a minute or two to jot those down. if anybody had topics that are kind of beyond the confidential AI and workload identity.
And maybe to throw in, I would also be very happy to receive some proposals for people to speak more about technical stuff. So we've had some discussions about what companies are doing, what startups are doing, some open source presentations, but like some deep technical discussions are also interesting to I think to have here. And so if you want to have like a deep tech talk, let's say, then that would be very, very well received. And we can also have a discussion about this. If you just have the topic idea and might know someone, feel free to already send that our way. And we can try to make that happen. I already have some academics for papers on my list that I will reach out to. But yeah, would be very cool to see a more variety of these talks in this year.
Yeah. So a couple things that were in mind for me that I didn't jot down that I was kind of wondering to hear if we'd have other people out there mention kernel stuff. So I think that was a lot of the topics from FOSDEM, where kernel means, KVM, QEMU, as well as things more directly within hosted guest kernels. And I just lost the train of thought I had with the other ones, but oh yeah, so companies, especially companies that are already contributing to core confidential computing work, especially those of you who are voting member representatives, you have a lot of big stuff going on inside your companies that eventually you want to externalize. The sooner you externalize it, it sort of that helps with the adoption of what you're doing. So please help source those so that we have intentionally generated talks. And next bullet on there is Fritz and Rian and I and Reinu spend a lot of time trying to manage the logistics of telling speakers or helping speakers find out how to connect, how to get scheduled, that sort of thing. So Fritz has volunteered to get some of that together on a fax so that we don't have to do quite as much answering of the same questions each time.
And it's coming.
And then
Pinky promise. I just didn't get to it.
Yeah. And then FOSDEM. So Fritz helped put this together. I wish I could have been there. So I'm hoping that we get a little taste of it from Fritz this morning or this evening, depending on where you're at.
All right. Do you mind if I take over the share?
That would be delightful.
I considered to put it into the slides, but I decided against it last minute. Let's do this. So I'm not good at Zoom screen sharing, but this should now show my screen. So FOSDEM, if you don't know, is a conference or an open source conference happening in Brussels every year. And it's special in the sense that it's completely free to attend. It's organized by volunteers. And the idea is more to talk about FOSS software and open source in general between developers and hackers, and do that in kind of this free environment of the campus of Brussels. And so it's always over the weekend because that's where the campers can be volunteered freely to this event. And then at that event, there's like the FOSDEM organizers, and then you can kind of rent a room, in quotation marks, rent from them. For example, you have all varieties of the open source ecosystem there. Go has a room, JavaScript has a room, right? LibreOffice, all of the folks. And for some years now, together with some of our colleagues, I have been organizing the confidential computing dev room at that conference. So that basically means that we have half a day, well, this time it was on Saturday, to meet in this room and freely talk about confidential computing. And I won't go into the details of these talks because I will actually put this in the chat. You can just go to the website, watch the recordings. They're currently coming online. So I think they're still in the process of being uploaded. But you can, I guess, in a few days, see these talks online. But what I want to go into is I can just quickly share just a few of the things I said during the opening. You can see my screen still, right? Because I clicked around to open
Yeah, we got it.
So I always make like a short intro in the dev room to show what types of TEEs we have, right? And I then always try to map this onto what talks we have at the dev room, right? And so I did distinguish it into like process isolation for SGX style things, trust on style, world isolation. I also put RISC-V in this one, and the more recent versions of VM isolation types. And interestingly enough, this year we saw most of the work and most of the presentations that we got interest from on the VM isolation. So I think that's not a surprise. It kind of probably shows what we are already seeing and having in our discussions. But it's just always interesting to see this also kind of this visually in a schedule and in the presentations that we keep seeing and that we have coming in. And we actually only had one research paper on SGX here and one RISC-V based research work. So this is really mostly kind of stuff in production, and in this industry is doing VM-based stuff. And then there's still some research going on things like RISC-V that are still spawning up or a little bit more niche at this point. So that was interesting to me to see. And then maybe just to give you some numbers that are always also interesting to just show how big is our community, right? How many people do we actually have going around that go to, let's say, quotation mark, more normal open source conferences nowadays? Last year we had 25 submissions and could accept 8 talks. And this year we only had 15, but we also have an attestation dev room. So this year we were able to split up our efforts into attestation and computational computing. And overall, we had actually, it's actually 20 talks. I found one more after.
And can I add to that as well? Because the attestation dev room also ran a workshop on the Friday afternoon, which had
I was about to get there. Yeah,
several. Oh, sorry. There we go.
No, because I wasn't there. But if you want to comment on that, please do. So now I want to get into that exactly. So I spoke about the computational computing dev room now. And so we had like 9 talks there, but on the day after we also had the attestation dev room. And so there was a similar wide variety of attestation topics there. And exactly as Mike just said, we also had an attestation workshop on Friday. I think Friday, the day. I unfortunately couldn't make it. Maybe someone can pitch in with a few words after I.
Yeah, I made some of it, but I couldn't do all of it. It was really interesting. More towards on the academic side, I'd say specifically, but some really good stuff that I did catch. Lots of ARM stuff, which is nice to see, but discussions about what attestation looks like, and have some very deep dives as well. It's good. Certainly, the stuff I really enjoyed.
And so I'm very happy to see that this FOSDEM community, or we're starting to grow as a community and even dive into like, let's say, the general FOSDEM audience. So I think I had it here. So there were actually, for example, 2 talks that didn't have anything to do with our dev room, but that applied AMD SUV, for example, in the virtualization and cloud infrastructure dev room. And then some OVMF talk in the open source firmware, BMC, and bootloader dev room. So our topics seems to start branching out into related communities, and it seems to grow. And so that's something I found cool. And so overall, we had roughly 20 talks at this conference where I think sometimes you can be happy if you have one on a topic, because space is always very tight there, because it's just a small campus for thousands of developers. And I think we're starting to really see some good traction at FOSDEM, which I'm always happy to see, because it's great. Since it's a free event, you just have to figure out travel there. But it's also very central in Europe. So at least in Europe, it's a good place to be. Yeah, and now if you have also notes, please feel free to pitch in. We also had a social event actually on Saturday evening. So we organized with one of our dev room organizers, also took her time to also help out with that one. And yeah, we had, I think, roughly 50 to 80 people at that social event to just purely talk about confidential computing in a more relaxed setting, because all of these back-to-back talks make it sometimes difficult to have discussions. But yeah, so that was a nice addition to a dense weekend of lots of CC talks. And yeah,
So-
feel free to watch. So I put the chat already. Sorry, Mike, just last thing. I already put the chat in the link in the chat. Check out the confidential computing and the attestation dev room. The slides should already be online, and the videos will come online soon. So hopefully you can learn something from there.
Yeah, I was just going to say, do you want to say how big the room was? How many people we could get in it? Because it was full for pretty much all of the time, right?
Yeah, so this time I think we had the 80 people room. I think it was
There's
80.
sometimes more people than that. There's more people than there should have been on occasion, which is nice, right?
Yes, yes.
And in fact, it started at 10, I think, on the Saturday. And after the first couple of talks, I left because there was a queue outside the room of people trying to get in. And I thought, no, I'll watch these talks later on, or it's stuff I know anyway. Let's get people from the community in. So that was really nice to see people queuing to get in into our favorite topic, right?
Exactly. So yeah, we'll try to organize this again next year. It's always a little bit tricky because FOSDEM has limited space. So I think it's there's not space for every community every year. But we can definitely, I think, make space and in and or around FOSDEM to continue some CC talks and the social event, because I think our community can use it. So thanks for that time. I think.
Well, thank you for all the organisation, to you and everyone else who was involved. It's really very much appreciated. It's spreading the word and doing the technical world a lot of good as well. Thank you.
Appreciate it. Thanks.
Yeah, that's fantastic. I say this every year, but next year I'm going to get to FOSDEM. I hope it's really true this time. Always sounds like a blast. Before we get to Mark, was there anybody else who was there? I think Fritz kind of already asked for feedback, but like if you learned one thing at FOSDEM that was kind of like a surprise, I'd be curious to hear that. But maybe feel free to drop that into chat if you didn't want to come off of mute just now. Two other thoughts before we get to Mark's section. One of the things I was trying to think of when we were talking about these Tech Talk recruiting is that both for FOSDEM and for OC3, there were more talks submitted than people could present. So if you know people in your companies who submitted those talks and you think that they'd be welcome in this forum, that's something to reach out to Fritz with. Because I know there was a lot. I was on the selection committee for OC3, and the number of talks that will be at OC3 is much smaller than what submitted, and some of the ones that I scored very highly didn't look like they made the cut. So I think there's a lot of good stuff out there to be discussed. Catherine, thank you for joining. I just wanted to check live. We had a thread about the kernel SIG not being scheduled for 2025, and there was a topic that was requested from the coconut community, and I just wanted to check back with you and see if that got sorted out. I think Steve might have been on point for that, but if you can kind of proxy what he may or may not have gotten sorted out, that would be helpful.
Yeah, apologize for being late. I have not followed up with Steve. I will follow up with him and get back to you on that.
Okay, thanks. So for everybody else, just kind of look for updates on the timing for that if the kernel SIG is something that you track. Okay, finally, one of the main events of the day, workload identity. Mark's introduced this last month. This is something that I think is super important for our community. We often sell the value of confidential computing by being able to strongly identify a workload, but there's a pretty big gap between the aspiration of doing that easily and being able to actually do that in practice. And it looks like Mark would like me to share slides, so let me bring that up.
Okay. So I have, I can share my own screen so I can scroll through it and you don't have to.
That would be
Let's
great.
do that. Okay, let's do it. Okay, so hello everyone. I'm a frequent lurker on here. I've been involved in confidential computing for almost 2 decades now, so probably longer than the term existed. Many years doing related things at Microsoft, like virtual secure mode. And now I am one of the flag bearers for this technology at JP Morgan Chase. So name dropping here. So I basically have a large wad of cash, that I'm carrying, I'm looking to give away. So with that, let's talk about this topic. So, by the way, I said workload identity, and I want to make a case here that I also believe that if we crack that nut, we're also going to get zero trust, at least one of the 3 tenets that perhaps the most important. So, 2 birds with 1 stone, never a bad thing. And I only have 5 slides, so I think what I want to do is feed a discussion. So let me just very quickly go through what it is I'm want to sort of propose, but then after that it will be a discussion. So first of all, I joke often that confidential computing has 2 classes of customers: the paranoid and the regulated. The regulated are the ones who will pay the bills, and this is a very large addressable market. And the reason it is because regulations are coming online that, if we do this right, will make confidential computing the way to meet the regulations. And that is not a small feat. So when regulations come online, and I'll give you a little anecdote on this that you may have heard me say, there is no particular use of technology mandated. So if somebody says protect data in use, and we basically say, well, we put armed guards around the server, and we I don't know, sandbox it in some other way, that will be fine. Nobody says data in use protection equals confidential computing. I don't think anybody in their right mind is going to use fully homomorphic encryption for AI, but it still doesn't mean that the use of confidential computing will be mandated. So the real question is, when these regulations come online, how are we going to position confidential computing as the winner? And spoiler alert, it's not right now. So the other regulation that's coming online is something that is perhaps not obvious, but there is a growing mandate that we harmonize the use of human and non-human identities. And there is a recent blog post by Ryan Hurst on this, on his Unmitigated Risk blog. You can check that out. But we have European Union's CRA that basically says you need to show us what bits you have running in production. So that calls sort of secure bills of materials into place and knowing what code is running where. Singapore, Luxembourg, go down the list. ICO in the UK talking about privacy enhancing technologies. It's a kind of a barrage. Now, the reason I know all this is because my employer operates in over 100 jurisdictions worldwide. So we have to meet all of these regulations. And another regulation or sort of mechanism that is gaining prominence is ZTA. Now, I wrote a paper and I attached it here that basically argues that confidential computing is the way to meet the zero trust NIST, zero trust architecture requirements. All 7 tenets, which is not a small feat. So that's your addressable market. That's the market need. Now let's talk about where we are at. So this is where I'm saying the current use cases are severely limited. So again, using my employer, it's probably one of the world's largest IT shops. I don't know how we compare to the US government, but we're kind of up there. 250,000 employees. The yearly IT spend is in excess of, I don't know, $12 billion. Right, a big chunk of that is, of course, my salary, but even the rest is still pretty big. The number of existing applications is in the mid 4 digits. And when new regulations come online, all of those applications need to comply with the regulations. Now, nobody in their right mind right now can argue that confidential computing can be used to seamlessly or relatively painlessly shift all these applications onto confidential computing platforms. And the biggest obstacle, actually, even if you assume that you have all the hardware in the world, which is, we're getting there. So let's assume that. The way confidential computing runs right now is you test your workload, you go to some KMS with that attestation result, you download a decryption key. And that unlocks for you all scenarios where your computation happens in a confidential computing enabled environment, and the data is already encrypted for you to download and decrypt it. Now, you also know that probably vast majority of data out there is not of that variety. There is some database that encrypts its data at rest, but it's really, serves it to you over rest in the clear. So confidential computing can't be used in that environment. Or if you have a workload that has a contact some backend, like there's no end-to-end to it. Right, so this is my second to last bullet is key here. So if you work away with one thing, relatively seamless adoption and migration are absolutely essential to the marketplace success here. So we have legacy approaches. So you go to GitHub, you scan for private keys, you get a bunch. Now you can attack a bunch of places. So massive source of breaches. Or even in the best case, you still have to go fetch the credentials. There somewhere in your orchestration framework, put it on a disk, mount it inside the container, read it in the clear. There is a lot of leakage that can happen in that process. So ideally, you'd actually don't want to imbue your compute units with credentials. And I'm arguing that the way to do it is for them to generate their own and to go certify them, get certificates, and just like off to the races with everything else that's already out there and works. And so lateral movement is probably one of the biggest sources of security breaches right now. So you have Spiffy. Spiffy is great. I noticed Peter Castleman was here. He's a director of program management, project management for Spiral. So it's fantastic that Spiffy exists. Spiffy is very cleverly architected, and it unfortunately architected in a way that's completely at cross purposes of confidential computing because it requires node attestation. And on the confidential computing, you actually want to eliminate the node attestation. You want to attest the workload, not the node. Right, so we need it would be lovely to adopt it, but we can't. So maybe we can change that somehow. There's this whimsy working group, and I'm not even mentioning everything. We should probably, one of the items would be to collect all the existing approaches and figure out what can be done in either case. But the end state is your VMs, your containers, your lambdas, your step functions, whatever does computation accesses the data needs to be able to run confidentially and do it end to end. This is how you achieve your upgrade. All right. So I made up a definition, so this is me. And by the way, everything I say, I'm opinionated, but I am often also wrong. So with that in mind, workload identity is strong. And that's what I call strong workload identity. If the workload generates and protects its credentials and associated keys while in use, and the data in use protection, which has been until now the key selling point of confidential computing, I argue is actually downstream from that. If my workload can generate and strongly protect its own keys, well, pretty much can protect all the other data that's entrusted to it, because it would be running inside the T and everything's happy. Right. So what is beautiful about that? So when I say harmonize human and non-human identities, this is actually better, because the keys in this case are short-lived. You do not need to store them in an HSM. You do not need to lifecycle manage them. So you don't need all the associated controls and overhead. Right. You don't need to use bearer tokens anymore, so you don't get lateral movement. You don't get a lot of those headaches. But you also need integration with CI/CD pipelines. You need seamless workload upgrades. So there again, I uploaded this Musings MD file. There's a link at the end of the presentation, so you can read all of these things. This is just very, very high order bits to keep the presentation strong, and I'm almost at the end. So where do we go from here? I am proposing that the consortium spins off another SIG that would probably be very closely aligned with attestation SIG. And again, it's a proposal. We take it or leave it. We start collaborating with other parties. Mike, I see your hand. I'm almost done, and you can be next. Right, so figure out what these outside parties are in terms of existing products like Spiffy, also in terms of working groups out there in the world like Whimsy. Let's find out who the others are. And the success criteria, again, they're listed in the Musings file. You can read them for yourselves. And with that, here, I put the link in the chat so you can see it for yourself. Click on these links. But this is the Musings. These are the requirements and key properties of a solution as I see it. The Whimsy architecture, which again, we should probably participate with them because they said they don't want to work with us. The measurements are too fragile. Upgrades can't be supported and so on. So again, can't catch up on that. And my final document here is an argument in favor of using confidential computing to achieve all the tenets of zero trust architecture, which is again an absolutely huge factor for adoption if you're going to talk to regulated institutions. And with that, I yield. Mike.
Thanks very much indeed. Just to let you know that NIST is about to kick off an identity piece of work, which I think is likely to look like at least some of this. And I say about to kick off, that's in an hour and 13 minutes because I'm on the kickoff call. So exactly where that's going, I'm not sure, because when it was discussed, it was about 4 months ago, and I can't remember exactly what we agreed. But I agreed to be involved because it looked like this sort of thing, I think. So hopefully that set of people will be people to be in touch with, and I should be part of those people as well. So I think that's a useful thing, hopefully.
But Mike, it's more than just identity, right? So how is confidential computing used in zero trust? It can touch a lot of pillars, and if we could bear that out together, that would be a great thing. MITRE would definitely want to support that, Mark.
Yeah. And I will also say that zero trust, so there are 3 ways to do zero trust if you read the NIST document. And the one about strengthening the software is actually, once you solve identity, you also solve that. So read my PDF, that 3rd bullet on my presentation. Again, welcome feedback. But yes, you need identity. Yes, you need zero trust. I'm just arguing they're just so close to be almost indistinguishable.
Mari, I will absolutely look to being in touch with you as well. And no, I don't think that the NIST stuff will cover everything, but it's having something we can point to which is NIST relevant and which hopefully is congruent with the stuff that we've been talking about here is hopefully helpful.
Yep. I've been affectionately using a term in software, secure software supply chain, safe harbor provisioning, using the identity attestation capabilities of confidential computing to ensure that you're always deploying to the hardware you trust as in a DevSecOps pipeline. It does require a lot more tooling up than folks are ready to do and have the will to do. But this is what I push at MITRE, and I call it safe harbor provisioning, typically.
Thanks. Manu, I think, has got his hand up as well.
Yeah, so a couple of things. Mary, we should probably connect. MITRE is actually doing a deep dive analysis of the infrastructure that we're building. So there may be some interesting connections there. Then going back to the workload identity thing. So we create our company, our startup was created on the realization that if you wanted to have true zero trust globally, that you would have to remove the humans from the the association of data with identifiers. And today, if you think about all the data systems we have, if you use human readable identifiers, which are file names, traditional file systems, domain names, any of those identifiers that are visible to humans, the association between data and identifiers can only be relational, and the binding between the two has to be external to the data and the identifier. So it's the system that maintains the association that needs to be trusted. And so you end up with this total all the way down problem because you don't have an inherent binding, an inherent mathematically verifiable binding between the identifiers and the data that you're trying to that a process, so that a workload is trying to refer to. And so what we realize is that if we were able to use cryptographic identifiers, the way we call them STEM identifiers. And those are identifiers that are completely random, generated from within a TEE with a length of at least 256 bit, which gives us essentially the identifier becomes both an identifier and a symmetric key. Then we can bind or mathematically unite data with that identifier by using key derivations, HMAC function, which is a fairly straightforward, high performance, quantum resistant operation. And then through key derivation from that STEM ID, we can then mathematically encrypt data with the key that are derived. And that gives you a primitive that we call STEM encryption. Encryption with keys that are derived from a STEM identifier or with keys that are themselves STEM encrypted. That recursive last bit is important because it enables you to then generate new keys or new identifiers and then chain them. That gives us the ability to then create a blueprint that can scale, that is hierarchical and recursive, that can scale horizontally at internet scale. And so I know this is kind of abstract, but essentially the ability to then identify all types of entities, not just workload and humans separately, but really what we're trying to achieve is the chaining of a specific individual acting on behalf of a specific organization is pushing specific bits onto a specific physical machine. If you want to do this in a verifiable way, it has to be done by software that itself runs within a verifiable piece of hardware. And so what you the requirement that you end up having is that all the identifiers for all these types of entities have to be part of the same namespace. Because if you have different namespaces between different types of entities, somebody has to bridge those namespace saying, hey, Alice over here is Alice over there. And that external authority reintroduces a dependency or reliance on humans or systems that are external to the attestation and verification process. So
Thank you for that.
Come again?
Yeah, no, thanks for the download on that. I want to give time to
yeah, just to finish the thought here.
Oh, sorry, I thought you were done.
Is that I think from a CCC standpoint, I think that's the overarching opportunity is to basically, you can only use those cryptographic identifiers within, of course, trusted execution environments that would protect them when in use. And so this creates actually a blueprint that directly aligns with what Mark is trying to present here and what I think the CCC has an opportunity to solve.
Awesome. I like the super binding. Super binding. Awesome. Thank you. I'll call you, Manu.
Okay, Nicholas, and then after Nicholas, I'd like
Yeah.
to start trying to get into some actionable next steps.
Right. I have a question to one aspect you mentioned, Mark, which stuck with you. So you did I read that right, that you say that you have first the workload identity and then data in use becomes the downstream effect? Because so far I was always like and we are doing it with like that you have, for in our case, like a system with an identity, which is then protecting data in use, or the basis for the data in use. So you know that your workload running has basically that environment. Otherwise, your secrets, your HMAX are all already out in the wild. Right?
So there is a system. There is a hardware on which your machine runs, for instance, or your compute workload runs, and then the workload itself. From the standpoint of regulated institution, your hardware only matters as far as its location, for instance, like things like very, very high level attributes, like for regulatory reasons, you can't process German data outside of Germany, right? Things like that, right? The rest of it shouldn't matter because it's outside of your TCB. And again, broad strokes here. So workload identity is what actually matters, not your TPM's identity, like broadly speaking again. So yes, when I say workload identity, I mean workload identity with perhaps a few hardware-derived attributes.
Okay.
That's good clarification. I think, yeah, a lot of times, especially with the increasing interest in VM isolation, the attestation of things that are kind of separate from the workload can get conflated with the workload itself. But so we don't just have discussion without outcome. Let's see if I can share the right window. I've stolen out of Mark's deck one of these slides with some of these next steps here. So just maybe going back for purposes of organization of the TAC voting members, though I think we're still a little bit light here in live view, but I know that Alec and Paul both mentioned they would check minutes and recording. Is that this isn't the best list to look at, but we have that's what I was looking for. Each committed to do something, and it's a lot more rewarding to be able to have a work product from the time that we spend together in these meetings and outside of these meetings. So when you reflect on the things that you have volunteered to do for the year, if there's something that feels more tangible in this list of next steps from workload identity, please consider picking that up. So let's go maybe sort of one by one here. So with the idea of seeding a new project, it's probably good to have a good understanding of the list of projects that are out there. And if there's some space, then maybe we can kind of intentionally build one together. What tends to be more frequently the case is there is an existing project and we bring collaborators to it.
Well, I guess my only comment on that, sorry to interrupt, Dan, is a project is usually a point solution, right? So you can say, well, Verizon is a project, and okay, so it becomes something that people can build on. But when we're talking about workload identity, we are really undertaking work that's closer aligned to something like Whimsy, right? We're talking about a set of protocols. We're talking about set of requirements, right? And a project may be more of a proof of concept. Again, I'm just spitballing here. So where I say a SIG, much like we have the GRC SIG, where we're developing patterns and standards, and we're doing the reach out, and the output is, do these things, and you will, have a governable system. This is similar, like do these things and you will be able to migrate your workloads onto confidential computing. Again, your thousands of applications written in JavaScript and Python, you know, that is your target demographic.
So are you looking mainly for, it sounds like you're not looking really for software, but more for sort of standards or RFC type work?
And advocacy and influencing, right?
Okay,
Because
so
the success
project means something very specific in the CCC. Sorry, just to be clear, which is an open source project like Verizon or NARCS or one of those. So I think probably we mean SIG or work group or something like that. Yeah. Okay. So right. Okay.
That's why I'm personally advocating for a SIG or a similar construct. And attestation SIG simply too busy to doing too many things that are not related to this, but would be a very key part of this, because I mean, again, I've complained loudly that attestation in confidential computing is like a disconnect from identity provisioning.
Okay, so yeah, so that's good, kind of teasing apart these things. So you mentioned Spiffy, which is the implementation of the Spire spec. There's also the SIG store collection of
I think it's
projects.
the other way around.
The other way
Spire is
around,
the
yeah.
implementation of Spiffy.
Sorry, thank you for that correction. Yes, so Spiffy Spire, in toto. There's a list of these, and I wonder if there's a volunteer who would like to make, maybe not an exhaustive list, but maybe the most germane list of projects that attempt to use workload identity, either correctly from our point, from an attestable point of view, or maybe incorrectly from a CCC point of view of things that are not really cryptographically secure identifiers.
So you're asking
something
for someone to come up with a survey, basically, of available or relevant work here, yeah?
Right, and the idea is that when we look at that list, is there one or two or three projects where we want to try to recruit people from our companies to go participate in those, make sure that they reflect confidential computing, or is there actually a very noticeable gap in some part of the software stack where, I mean, the whole reason that we're here under the Linux Foundation is to make software together. So that's something where I would love support from the community to crowdsource that information. That is not to the exclusion of creating another SIG, but there's a few things that we need to do before we create a SIG, and probably key among them is to get to a charter. Because when we just kind of get together to have meetings about a subject without clear goals in mind, those SIGs aren't as successful as the ones where we figure out upfront what the problem is we're trying to solve with that SIG. The way that works to get there is to have a few informal meetings, get the like-minded individuals together, do some of that initial brainstorming, and arrive at a charter proposal to bring back to the TAC so that we have a directed plan of action.
So whatever working group is formed here, I would love to participate in it. Now, I don't need to run it. I am already chairing the GRC SIG, but it's a very key part of what I'm hoping to do for my employer and for the industry in general. I believe it's absolutely critical. So I'm very, very passionate about it.
So I think a good first step is to collect that list of names of people who want to contribute to a SIG. And maybe the easiest way to do that is to open up a globally accessible Google Doc and have people add their name and email contact. And then we can try to schedule something out of that. We would want at least one of those individuals to volunteer to sort of organize that meeting. So kind of chair, I guess. Unless somebody has a different suggestion of how to get that initial list of.
If it's the only way of
together.
getting it going, I'll take it on.
Great. So if you are like me, your organization doesn't allow you to create a globally writable doc, so Rian or Renu can help create the doc for you.
Well, so I can't commit to it just yet, but I'm in conversations with my boss about membership. So stay tuned.
Okay. Let's go ahead though and create that doc. I don't think we need anybody to particularly own it at first, but just to get the thing going.
Okay, let's just create a folder in Google Drive for just for this effort, and then again, let me do this. I will put my email address in chat right now, and if you email me and you're interested in collaborating, you know, we'll figure something out.
Okay. So like the idea of creating the list of related projects, another easy actionable thing is standards bodies or standards efforts. So Whimsy is listed here. I see Hank is on the call. Hank, are you already involved in that, or do you know maybe somebody from the CCC who is?
Sorry, this is Hank. I've been joined late. What's the exact context for the question for working on?
So the Whimsy working group for workload identity, what we've been discussing is trying to assert a confidential computing viewpoint of workload identity in the community. So specifically here for standards work.
Yes, so there is a interesting split between the workload identification working group. I think now my headphone works finally, sorry. So the Whimsy working group has a certain focus, and I think Mark, I think could already give a good overview about that. Last interim, very preliminarily, we highlighted how remote attestation for workload identity issuance can look like. I don't know, Mark, did you talk about that already here? Was that one of the success criteria, or is this off topic and too much in the details?
I don't think we need to stay high level here. I can tell you that the Whimsy interim working group meeting. So what I'm hoping that Whimsy will deliver is being forward compatible with confidential computing. The interim IETF meeting on Whimsy that took place in January, they at that meeting said the measurements are too fragile. We can't really deal with it. So we will need somebody who is influential inside Whimsy. I'm a participant. I'm not influential. To you know, try and strategize how to change their mind.
Okay, so we try this to do, and when I say we, I mean Hannes Schoppenig and I. We try to create a model where we reuse a certain building block that we created for this CSR remote attestation. So the CSR is a CAP forum mandated LAMPS working group to create something to put into a certificate signing request that conveys the trustworthiness or as evidence about the trustworthiness of the certificate requester. And if that turns out to be okay, / remote attestation appraisal of evidence, yada, yada, then ACA / registration authority is okay to issue a certificate, for example. That's a nice
That would be a very good
concept.
building block, yes.
Yeah, that is the very block that we almost have. So we have the vehicle for the CSR specification. That is basically done. Now people realize, well, CSR is ASM1. Why isn't your evidence ASM1? Yeah, because we are not from the past millennium. But okay, we can also do that as a backward interoperability thing. But typically you want to do web tokens here in CBOR and JSON, for example, or maybe even TPM quotes. And there are, this is essential in the middle layer, thin frosting, thin substrate. That is the conceptual message wrappers from RATs. That basically is the solve all how to put a conceptual messages from there in something. And so that exists as a draft form for CSR now. And now you could, in theory, have a platform. A platform is a very bad term. It's the host for, I want to say, the guest, which is then the workload, so many terms. So, but there's this layering in the confidential compute realm. And so the attester, the host can now not look into the workload because it's confidential. That's the point. So you basically have two attesters running here. One inside the workload coming from the application vendor, maker, creator, authority. and one that is on the hosting side of things. And kind of the consumer in the end doesn't want to have two processes, doesn't want to have look things, and that is maybe something that could be in this whole context a driver for customer requirements.
So that's great, and I would love to spend more time on that. In terms of giving time for our guest speakers today, we will have to move on. But the context was definitely, do we have representation in Whimsy? It sounds like we do. And then are there other standards efforts that touch on workload identity that we should identify and make sure that we have owners from consortium members participating? So we'll try to get into more of these actionable items in the offline discussions that we have. I will continue to allocate 30-minute blocks for this topic in subsequent TAC meetings until we really have a separate SIG spun up, if that is indeed the direction we go. But after all that hard work on these very important topics, now we have kind of the fun part. Maybe the fun part was doing some of that work, but we have our first talk, which was, I think, originally titled to me as Confidential Computing Carry On.
I apologize, Dan. Can I just say one last thing? 30 seconds. So I would like to move quickly on this. So perhaps, the interested parties in the space, if you reach out to me, we can schedule a meeting literally in the next couple of days, maybe tomorrow, maybe next Monday, figure out a plan of action, see how much we can accomplish, and we'll come back to the TAC in 2 weeks with a quick update on where we stand. Can we at least commit to that?
That sounds great. So Mark has dropped his email into chat there. I think I would still like to get a public doc up for people to post their names and contact into, so that we've got a very accessible place for that.
Great.
Thank you. Okay, so without further ado, I will ask our first speaker to take over control here.
All right. Thank you so much, Dan. Thanks everyone for the session thus far. Just going to go ahead and share my screen here. Slides. All right. Yeah, thanks so much for having me. My name is Jacob. I'm the founder of Elysian. We do cyber-physical security and verification for the AGI-H. We're a new startup, and we're trying to think across the data center stack from construction to silicon to software to protect, verify, and assure mission-critical operations. And we will be applying for CCC membership shortly. So I'm very excited to be here with you all today. And I'll be talking a bit about some stuff that is joint work with collaborators from across a range of organizations, both in the US and the UK. And some of this work is also covered by a sort of white paper that was commissioned by the UK government's ARIA agency in fall of last year, called Mechanisms for Flexible Hardware-Enabled Guarantees. If you want to find that, you can search the web for FlexHag chip. Probably the best way to find your way to that white paper. And roughly the plan for today is as follows. I'll just start with some quick background. You'll have to sort of I'll have to apologize for talking a tiny bit about philosophy and governance. Primarily, this will be a technical talk, and I'm sort of excited to dive into some of the technical details. But I'll need to kind of briefly situate why I'm doing this. And then the bulk of the presentation will take place as a live demo on our little data center in the box that we built. That Mike calls the Confidential Computing Carry-On. It's H100s and AMD SAP-SMP compatible motherboard in a little briefcase that we've been flying around across the world and plugging in different places and doing bare metal adventures, some of which I hope to show you guys soon. But so let's quickly get into the background. When I say AGI, I define that as a system smarter than almost all humans at almost all things. The reason I bring this up is because Elysian is an AGI company. This does not mean that we're building AGI, but that we're building for a world that we expect to be heavily reshaped by it. And I think it's important to acknowledge this because, of course, these are hotly debated questions. There is disagreement about how soon, if at all, we will have systems this powerful. There is disagreements about the implications for society, cybersecurity, and so on. And I don't want to use the time on this talk to like debate or litigate these questions. I rather want to sort of assume this premise that we might get these like extremely capable algorithms and then explore the implications for confidential computing. So depending on sort of where people's background assumptions are, this will either feel very relevant to you in the coming years, or it will feel like a kind of hypothetical thought exercise. But like any startup, you know, I think you need a contrarian bet or a vision of the world that you're building toward, and this is sort of the contrarian bet of Elysian. We expect to have very powerful AGI systems very soon, and we sort of think deeply about the implications of that. All right, so in a world of AGI or systems that are smarter than almost all humans at almost all tasks, what are the technological demands on confidential computing? Might we need to have a conversation about the changing threat models? Here's a sort of hint or a puzzle for you to chew on until later. What threat model has always one insider? I'll sort of get back to that later. But yeah, and so to second, you know, brief background before I get into the technical stuff. I'm currently in DC en route to Paris. There's this big event happening next week, the AI Action Summit. People are flying in from all over the world. Some big suits, like the Vice President of the United States. And a lot of companies are releasing these frontier frameworks for how they intend to manage building toward and deploying advanced AI. So here we see frameworks from Anthropic, Google DeepMind, OpenAI. And I'll just like briefly go into like Meta's framework that came out a few days ago as a sort of reference example that we'll be like kind of working with.
Which conference you're talking about?
Oh, the conference is the AI Action Summit in Paris next week, February 10th to 11th.
Are you in Paris?
I'm currently in Washington, DC. I'm flying to Paris in a few hours.
Excellent.
I'll see you there. I'm
I'll
there
see
on
you
the
there,
Sunday. I'm on the 9th rather than the 10th and 11th, but I'll be there for the AI Security Summit on the Sunday.
Looking forward to it. Anyone else who happens to be in Paris, feel free to reach out.
Can you please put the name of the conference on the chat? I didn't get it.
Yes, sir.
Please.
Somebody can do that for Jacob, so he can.
All right, sure. Yeah, I'll continue onwards.
Yeah, sure.
This sort of Meta's framework here. It has 3 steps: anticipate risks, run threat modeling exercises, evaluate for performance and safety, and then kind of decide on whether to release a model or not. And the kind of risks this system looks at is cyber risks like automated discovery and reliable exploitation of critical 0 days, or sort of chemical and biological risks like proliferation of known medium impact biological and chemical weapons for low and moderate scale actors. And here's a sort of first confidential computing hint why this might matter, because this is obviously very sensitive data in some of these data sets to evaluate these potentially dangerous capabilities. And you want to apply them to sort of pre-release models with extremely crucial IP for the companies involved. And furthermore, as part of this framework, Meta has sort of 3 categories for making release decisions. The first, if the risk is judged as moderate, it's approved to release. If the risk is judged as high, the systems are to be not released. And if the risk is even judged as critical, they suggest stopping deployment of the systems and limiting access to the small number of security experts. And that's the sort of second confidential computing hint, that how might you verify compliance with this kind of sort of far-reaching policy governing your development process. All right, enough talking, enough philosophy, enough governance. Let's have some fun. Let's do some computing. Let's look at some other stuff. So I'm going to quickly switch to my phone camera, so I can show you this carry-on box I'm going to be talking about. Let's see. All right, Dan, is there any way you can put up my phone camera on the screen that I just had joined the meeting?
Sorry, what is it you would like me to do?
So I just joined the meeting with my phone. If you can see that, is there any way you could sort of?
I think people have to choose to see
yeah.
that themselves.
Oh, I pinned it, if that helps.
Yeah, I think
Yeah, so you can pin things individually for yourselves. So if you grab
let's
the
just
demo phone
Pin.
user.
Yeah. Okay. Right click on it and press pin. Yep.
I think I have a way to do it for everyone, actually. Real quick. So I have to set it on fast. All right. Everyone should be able to see this. Oh no. Okay. Okay. So okay, can people see my phone screen right now?
Yep.
All right, awesome. Okay, yeah. So here is our little confidential computing carry-on. We sort of put this together in a sprint, 6-week sprint last year, for the purpose of being able to iterate on sort of data center scale problems, but from our office, as a little startup. So we of course have the H100 in the middle, motherboard from Supermicro. It was quite an effort to find one of the only few motherboards small enough to support AMD STD-SMP or Intel TDX. But Supermicro has 2 models, so thanks so much Supermicro. It runs with NVIDIA Connect X6. I should clarify also, this is not the product pitch. I'm not here to sell this to any of you all. I think you have enough bare metal servers. This is just kind of like a fun, research demo that we built, and so which is why I'm highlighting it. We also have here did a custom PCB that just monitors input power to the GPU at something like 10 kilosamples per second. And I'll go into the purpose of why we're doing that, and it will relate to sort of interesting confidentiality, potential vulnerability. And we have an AMD 9334 CPU in here. This little guy sits in these kind of earthquake springs. I've been taking this on a plane all across the world to DC and Paris and Washington. TSA often kind of love this guy. They ask if you can play games on it. Some of them say it's the coolest thing they've ever seen. But people are generally pretty excited. We had to kind of 3D print here a custom duct to handle cooling and optimize for having a set of sort of tiny fans with high throughput. And after doing so, we can now sort of run the full burn test of the H100 and it kind of plateaus at 75 degrees Celsius and runs kind of in the box without any cooling issues. So that is our little data center. We're not a hyperscaler, so we make do with what we can and build our own. And I'm now gonna drop into this box.
Your audio is good.
Give me a moment to check if there's a fire alarm in my hotel.
Seems it
Okay,
runs hotter than he thought.
Yeah. So they're doing some kind of fire alarm test. All right.
Good thing
Cool.
you can take all of the valuables in one package, huh?
So yes, the good thing is that packing this into a box, no one really knows what's inside a tele case. Looks like the most boring black box ever. All right. So here's what this guy looks like on the okay, this is ridiculous and the most unfortunate thing imaginable. I think I'm straight back to this hotel right now. And I all right, I'll check with my colleague if and maybe you can move to the other lightning talk and maybe I'll be back in a 20 minutes or something.
We can always schedule you again next session if you're available.
Yeah. Well, hopefully I'll see you all soon, but I have to evacuate the building now.
Okay, thank you.
So thanks for having me.
Take your luggage. Good luck.
Keep safe. Take your passport.
Point.
Well, that is a first for, I think, everybody here. So fortunate for Jacob. But let's go ahead and follow his suggestion. Let me navigate back here. I won't start sharing again so that I can immediately let us switch to Jens. He's got a talk on a secure proxy. Also been waiting for a while to get in for a tax session. So I'm glad that we're able to make time for Jens, and it looks like
Vladimir, yes.
Vladimir as well. Great.
Yes. Yeah, thank you very much for taking the time. That was very interesting, Jacob. Hope he's all right. But I'm very keen to get hands on this box too. That was interesting. Yes. So what we also, in the interest of time, what we would like to do is Vladimir will run, our VP of Engineering will run through the presentation. If anyone has any questions, feel free to put them in the chat. I will pick them up and guide through it. Vladimir, you're around? You ready?
Yeah, let's do this.
Let's do this.
All right. Can you see my screen?
Yes.
All right.
Yes.
Cool. Yeah, so nice to meet you all. My name is Vladimir. I'm VP of Engineering at FrontierX, and today we want to talk a little bit about our technology to build what we call secure containers. And of course, everybody here is very well familiar with confidential computing. So we're thinking the angle we want to show you is how confidential computing can help prevent breaches, data breaches. And this is how we market our product. We are a startup. So we want to sell it as kind of a easy way for people to onboard in confidential computing, but at the same time, it's fully open source. So everybody can look at the code, verify it, use it themselves. So when we look at the news, these kind of breaches happen often, and they happen even to the companies with the best kind of security team. So it's very hard to stay protected. And we were thinking, how do these breaches happen? And we've been looking into some of the past big breaches and trying to kind of put like the causes into 4 categories. One is just misconfigured data access policies. So people forgetting to make a bucket private, for example. One is unauthorized access to machines processing data, right? If an attacker gets access to the infrastructure, they could SSH into a machine that runs some operations and then download data. And then we have leaked credentials, either of service accounts or employee credentials, that are somehow privilege to access some data access, encryption keys, and so on. And to kind of group, why this happens, and we come to kind of two conclusions. First one is data is encrypted during processing. It's not encrypted while it's processed. And the second one is that privileged accounts have easy access to keys. And by this we mean, for example, if you use like a CMAC, it's often even transparent. The decryption becomes transparent. So these kind of accounts, if they are compromised, it's kind of easy for them to get access and decrypt the data. So the question is, how do we prevent this from happening? And in a lot of the calls, we're asked about certificates, and you can do SOC 2, SOC 3, ISO, and so on. But since we are not on the compliance automation consortium, the answer is not certificates, and it's surprise, surprise, it's confidential computing. So what can you do? How can confidential computing help? And of course, we can just run something on AMD SAV or Intel TDX. We get encryption in use, and that's great. But now our data is actually not stored into the TE, it's stored somewhere outside, and the keys are also stored externally. So we also need to somehow prevent the keys to only be able to be used in the TE, right? We can use remote attestation and so on. But then, this still doesn't mean that nobody can SSH into the machine and actually inspect the data, right? There could be like a super user account that has this ability. So what we are also looking at is how to basically enable the key to be released in the TE only if you can attest that the machine, you cannot get direct access to the machine. By direct access, I mean SSH. And then what if somebody, deploys a compromised account, deploys a new software version to this TE that actually starts leaking the data, right? So ideally, we also want to achieve attestation of the workload that's running inside, and to have an approval process and say, okay, we are only allowing the key to be released and the key to be used to decrypt data by this specific software version. And so this is much more difficult than just, running your workload on a machine with AMD SAV enabled. In fact, we've actually started using confidential computing for some internal products, and we saw there's actually quite a lot of work to build all this infrastructure. So we wanted to make it easy. And for this, we tried to make a product out of all our internal efforts to protect ourselves and our own products, so that this can be useful to other people that may have similar challenges as we have. And this we call Polaris Secure Containers. And the main idea of Polaris is to be a transparent wrapper around your containerized workloads. So you can think about it, if you have some kind of application or backend or processing pipeline module, if you have a Docker container running on your infrastructure, you can put a wrapper around it by using Polaris. And this wrapper tries to be as transparent as possible, meaning that you don't have to change anything or just minimally. So Polaris makes sure we run your workload inside of a confidential VM. So either AMD SAV SMP or Intel TDX. Polaris helps you provision your encryption keys, provision the remote attestation checker, and configure all the policies to properly. And also, as an optional add-on, Polaris can provide like a transparent layer of encrypted communication on top of what you already have. And Polaris itself, I like to think it consists of three kind of packages. The first one is deployment automation. So currently we have it on the Google Marketplace and Azure Marketplace. and we are working on a Terraform provider and Helm charts that you can use to deploy. And it's always on your infrastructure. You don't run any part of the stack. The second is the runtime library, or the so-called Polaris proxy, which can be used to proxy all requests and encrypt and decrypt the communication transparently. It also helps you with getting access to the keys to decrypt the data. And then the third part is the developer SDK that can be used if you want to have more things encrypted and decrypted, and for example, store them in a database. So it's basically like a set of utilities to make it easy for you to use it. And before we dive into the kind of the technical details and how this is implemented, just to kind of make clear some of the assumptions we have developing Polaris. And the first one is we want to build, we're a small startup, and we want to build on top of the latest and greatest from the cloud service providers, right? So we are gonna use services that are already available. And what Polaris does is basically makes it very easy for you to use all these services, deploy them, configure them properly. We want to be opinionated about the security configuration, meaning that we don't want, if you want to use Polaris, we don't want to allow you too many options to shoot yourself in the foot and configure something wrongly. And we want to hide as much as complexity as possible from the user, because our target clients are people that are not very familiar with confidential computing, but that care about this additional level of protection that can be offered. Transparent wrapper, we try to not get in your way and not require you to do any kind of modifications. Some parts at the moment still would require you to do something, but we are working on one by one removing these requirements and making it as transparent as possible. And the last one is everything runs on your infrastructure. So we help you deploy, but everything is running in your tenant. So we don't have any kind of component on our end. And we want to, everything we do here is open source. And you can find the main things on our GitHub, with the SDK being Apache 2, and for the Polaris proxy, it's AGPL3, and you can basically purchase a license through either the Google or the Azure marketplaces. And then let's take a look at the overall architecture of Polaris. So in the center sits your workload, right? So if you have any kind of Docker container running, it continues to run there. In the same node, we deploy the Polaris proxy as a sidecar container. It is the only component that's allowed to talk to the outside world. And you can enable optional encryption and decryption of requests and responses. Currently on HTTP level, but we're working on TCP level proxy as well. And the proxy is going to help you manage access to the keys, to the attestation policy, and the key that's stored in some kind of HSN service. We have an option to also add a GPU, a confidential GPU with a confidential PCI Express bus, currently only H100s. And we have you have currently the ability to use the Polaris SDK to encrypt things for external storage, but we are also working on making transparent, different types of storage transparent. So just attach them, and you can work with that. So now we can deep dive into the details. So for the trusted execution environment, we use confidential VMs or confidential containers on the cloud providers that support it. And the idea of Polaris is to be cloud agnostic. So we basically have the automation and basically the functionality to connect to kind of, currently we are on GCP and on Azure with AWS. Support for AWS is on the roadmap. We also support confidential GPUs. Currently, the technology is GA, general availability only on Azure, but we're also in the private preview for Google to enable this, because especially the case for confidential AI and confidential LLMs seems to be a hot topic right now. And then for how this kind of combination of the two containers looks like, as I said, the current Polaris proxy supports HTTP communication only. We already have prototypes for TCP level. And then when the encrypted request comes in, the proxy decrypts it, sends it to your workload, and then encrypts the response. So your workload actually doesn't need to know anything about encryption and decryption. And this communication is internal to the CPU, basically. So it's in the memory that this communication happens through is encrypted. It's an optional feature that you can enable, and then the key management makes sure that you connect to you perform the attestation, remote attestation in the proper way for the specific platform, send it to the KMS service, get it verified, and then get either credentials to the key or the secure key release, depending on the platform you're running. And for your workload, it's just like configuring a standard Docker container. You can configure the image, arguments, entry point, variables, and so on. It's very similar to how you would deploy a Docker container or on the respective cloud platform. And the encryption attestation, we support different ones. We have a version that's just uses ephemeral keys that are created inside of the TE. It's obviously not very useful if you want to have some kind of permanent storage. And then we support both on GCP and Azure. Their respective HSM offering, we always do asymmetric encryption with RSA 4096 bits. And for the attestation policies, we always check that the request comes from an AMD SAV-SNP environment with optional checks and attestations for you're running an image that has SSH disabled, that you're running a whitelisted service account, or that you're running a whitelisted Docker image hash. And in the way how we use it, for example, this kind of key and attestation policy sits in another organization. So there are no admins that have access both to the data and to the key and policy. For the encryption, so we use encryption, as already mentioned, on the HTTP protocol level or TCP, where the content of the packages is encrypted. You can also use it from the Polaris SDK if you want to currently store something on a bucket storage, for example. And what we do is we use kind of an integrated encryption scheme where we can use RSA encryption to encrypt a symmetric encryption key, to wrap it, and then this key is then used for with AES 256 GCM to actually encrypt the large chunk of the workload. So the advantage of this is that you can use private-public cryptography. So I can get the public key of the machine and I can encrypt already something and send it to the machine without needing to exchange private keys. And at the same time, AES 256 is obviously highly optimized and very efficient. It has efficient implementations on all kinds of platforms. And we offer, as I said, the Polaris SDK, which is basically a set of utilities you can use to make your life easier, that abstracts all the complexity of creating the attestation and getting access to the key. It gives you all the encryption routines with this scheme, gives you helpers for HTTP communication, can be used both on the browser or on the backend. Go implementation is currently under work. And to give an example how we use this internally is what you can basically use Polaris is to create an end-to-end encrypted chatbot. And this we developed for one of our internal products. So what happens here is you have your LLM server and rack application run inside of a Polaris container, right? Polaris container means we add the Polaris proxy, and we enable encrypted and decrypted output. This means now that you have some kind of chatbot application that has a front end, it has some back end. On the back end, you have a bunch of encrypted documents that you want to use. This is some kind of company documents you want to use in the rack context. And they're encrypted with a key, with the public key of the TE. And the corresponding private key is stored here in some kind of KMS service with an attestation policy in front. Now, what happens is if you want to make a request to the LLM, you go in your browser, you make the request, you type in your prompt, it gets encrypted in your browser, goes to the LLM, gets decrypted there, passed down to the rack. So the rack doesn't need to know about the encrypted HTTP communication. The rack can then fetch the encrypted documents. Usually what we do is we have embeddings that don't have any critical information, and we find the relevant documents, we fetch them, and then you can basically get this access to the key inside of the TE to actually decrypt the documents. Pass them to the LLM server, generate the response, and send it back encrypted directly to the user's browser. So in this way, we completely circumvent the need to go anywhere on the backend, meaning that we kind of have an end-to-end encrypted communication with the LLM server. With every step along the way, the data stays encrypted. And even this document, right, how we upload the documents is we encrypt them on the front end. When you send them out to the backend, they're already encrypted using the public key of the container that's gonna read them after. Right? So there is at no point this document was visible in unencrypted form along the chain. Now, one thing that you cannot do here directly or not simply is in this kind of LLM chatbot applications, you usually want to store your chat history, right? Which is could be quite sensitive, especially if it contains some kind of confidential company information. So one way to go is to basically put the database that you use in the backend inside of a TE. When you're working on this use case, but I wanted to show something else that we actually do. And again, with the use of confidential computing, is to say, okay, let's actually give every user a personal asymmetric encryption key that they can use directly from the browser. Right? The idea is I encrypt my messages, store them in the backend, and then when I want to read them, I fetch them from the backend, and I decrypt them live in my browser, so that I can avoid having the backend at any point see the content of the message. And this is another thing where we use Polaris containers for. So we're now the user. We are in our browser. The application has loaded the front-end code and running it. We authenticate with some kind of the identity provider. As long as they support OpenID Connect, it can work. And what we get from the ID provider is an ID token. The JW token basically stating your identity. This could be signed with Google, with Microsoft, or any kind of modern authentication system can support this. And then we fetch the chat history, so it can be any data, plus the wrapped AES-256 key that was used to encrypt the data. Fetch in the browser, this data is useless without the unwrapped key. And now we have a backend system that again runs in a Polaris container, which is like a simple key management API. What it does is it stores the private asymmetric keys for every user, basically indexed by their identity. And in this case, it's the email address. And then it's actually also indexed by the issuer of this identity token. So I can say, okay, for this email, if they log in with Google, you get this private key. And again, the keys are stored encrypted, only allowed to be decrypted inside of the TE. And this essentially means you have your personal encryption key stored for you inside of a TE in the cloud, and that you can access if you can provide the corresponding ID token. So you provide the token, you provide the wrapped key. We authenticate that it's you, unwrap your key, and send it back to the front. And this part actually never saw the actual data. It just saw the unwrapped key. And this part actually never saw the encrypted data, but never sees the unwrapped key. All things come together in your browser, it gets decrypted, and you see it live. So this is basically this extension how we can add this support for message encryption in the browser. And so we have 4 types of containers for different use cases. More simple ones we call Polaris. Polaris Pro adds the ability to use permanent storage, and we have special variants for AI and LLM that add some kind of let's say syntactic sugar to help you run easily AI models and LLMs. And that's basically it. Yeah, you can find all the open source components on GitHub. We have put here links to the docs and to the kind of product page. And then I was thinking if we have time, I could do a very short demo, basically just showing you how the deployment process works. So what you see here is so we have here a repo with examples. In this case, we have a very simple anonymization service using the scrub-adobe Python library. And then we have a client application that can communicate with it. Right, I have my service here, and this is now deployed without any confidential computing. This is just a bare minimum deployment. I can just submit requests, and it's gonna anonymize my data. Right now, the question is, okay, but what if somebody can actually get access, or cloud service provider do a memory dump? They could actually see this sensitive information, so I want to protect it. And I just want to walk you through the process of deploying a new container, which takes about a minute. So I'm going to go to the Google Marketplace. I'm going to select Polaris Pro. I'm going to say launch it. And as I said, you'll be able soon to do this all from your Terraform deployment using Polaris. I think I'm at number 9 now. And then you can just configure basic parameters that are typical for Google deployment. I'm gonna select an account that's gonna deploy this. You can also create a new one. I'm gonna select an N2D machine that supports confidential computing. I'm gonna use the default service account to actually run the application. I'm gonna stay default on the disk and the network. In order to demo this, this allows us to have a firewall exception rule that kind of allows everybody to talk to this container. And then we can configure different properties of the Polaris proxy. I'm going to enable input and output encryption. I'm going to enable CORS, so we can talk directly from the browser. And then I need to configure my workload. I'm going to use just our anonymization service, which we've published on Docker Hub. I can just plug it in. And here I can configure things like entry point, environment variables, and so on. But this is not needed here. And just click deploy. And that's it. So this now takes a couple of minutes to deploy. So I'm going to use a service that I deployed just before to show you. I think it's interesting to see the encrypted communication. So I'm going to switch to this IP. And then if I submit the request, it's going to fail, right? Because we are now trying to submit it in plain text. And we've enabled encrypted communication, so I need to do this. When we do this, what happens is you see we first fetch the public key of our container and then send the data encrypted with this public key. And we send the wrapped key for the symmetric encryption. This passes through the proxy, gets handed to the workload, and gets encrypted back. So you can see also the response is encrypted, and decryption happens live in the browser. And the last thing I want to show here is we also have an endpoint that shows you the attestation. So we can also verify it from within your own from your front end. So this basically fetches the attestation token, verifies it with the help of the Polaris SDK, and to show you it's verified. And if I come back to the deployment, the deployment is ready. I just want to show you that. So this is all the infrastructure that get deployed. So it's basically the a service account, a keyring, encryption key, the workload identity pool, and the provider with the attestation policy, the VM, and the firewall rules. So this is all kind of done automatically for you. So yeah, that's all from my side. So open for any questions.
Okay, that was a very complete demo. Thanks for that. So I'll open up to questions. Usually we want one to kind of seed the flow of questions. So I don't know if you're familiar with CNCF Coco. That project tries to allow you to target confidential computing using your existing Kubernetes workflow, and also tries to shield the container from the control plane. As I looked at your material, I gather that's not the approach you're taking with Polaris containers. Instead, you are, I think the focus is the proxy and enabling some sort of attested key release and then subsequent encrypted communications with that container. If I got that wrong,
Yes,
please
although
fix that.
deployment on Kubernetes is one of the areas we are working on, right? Our goal is to make it very easy for people that are not familiar to run this. And we've also focused on this kind of direct browser application to container communication, as we think this is one of the areas that may be interesting, or certainly very interesting for our use cases.
Yeah, that makes sense.
Yeah, we see very often decision makers about if are you using confidential computing, being CISOs or similar, that are not like with a super deep background, and when they see that a solution is wrapped and packed in this way, it makes it much easier for distribution of the solution, right? Makes it much easier for us to convince people to utilize confidential computing because there's a prepackaged solution basically.
Yeah, it's nice to see it up there on the marketplaces. Other questions from the audience? Well, I think that you have done an entirely too clear job of presenting so that we are not left with any questions. I think that was all pretty clear to me. So thank you for introducing us to the proxy. I think I've dropped the right link to the proxy code in chat. We do like to focus on the open source aspects of this, so people are welcome to go take a look at that.
Thank you.
Okay, and Jacob has arisen from the ashes, hopefully not real ashes, just simulated ones. And from chat, looks like we will get you scheduled next time, or whatever date is that we settled on there. Looking forward to the next meeting. We'll pick back up the workload identity topic. We want to move from some of the conversational aspects to actionable things and start getting the plans together. You have Mark's email out there on the chat for people to contact, and we'll get the document circulated on the list for further people to indicate their interests. And just going to quickly flip on my end to other topics that we have coming up for next time. The workload liaisons, so I touched on that at the outset of the meeting. Want to make sure that we're connected with our projects. And then we'll have another tech talk in addition to giving time for Jacob to finish up his. Any other topics? Hit the list with it, and look forward to collaborating with everybody over email and Slack in the interim. Thanks, everyone.